Hello there, Mr. Sutton here with the AB Calculus 6-1 classwork solutions on simple differential equations. For this problem, we want the general solution to this differential equation. I'm going to start by rewriting this as negative x plus 1 quantity to the negative 2 power, because my next step is going to be to take the general antiderivative of this thing, and that's easier if I have this in exponent form. So using my reverse power rule, this bumps up to a negative 1. Dividing by that, we've got x plus 1 raised to the negative 1 power plus c. And you could write this as 1 over 1 plus x plus c if you wanted, but we're pretty much done. On this problem, I want the general solution to this differential equation. So I'll start with my antiderivative, which is going to be y equals ln absolute value of x plus 3 plus c. But I can't have an absolute value in my final answer for these. So I'm going to use this. It's kind of an initial condition. They're telling us that x is always greater than negative 3. So if x is greater than negative 3, that means that this x plus 3 stuff is going to come out positive if I'm plugging in things that are bigger than negative 3. And if that comes out positive, that means I don't really need the absolute value symbol anymore. I can just replace it with parentheses. So then y equals ln of parentheses x plus 3 plus c would be our final general solution. For this problem, I want the particular solution of this differential equation with this complex-looking particular or initial condition. So for this one, I'll start with my general antiderivative, which is y equals negative 2 ln absolute value of x minus 1 plus c. And now I'm going to plug in my initial condition to figure out the c value. So we have a y value of negative 2 ln of 2 plus 1. All of that is just this little y value over here. And that's going to equal negative 2 ln absolute value of negative 1 minus 1 plus c. Well, this is just ln of absolute value of negative 2, which is just ln of 2. So if I have negative 2 ln of 2 over here, I can add that over to the other side to cancel this negative 2 ln of 2. So then all that's left is c equals 1. All right, now before we plug that back in, we have to resolve this absolute value. If x equals negative 1 from our initial condition here, then that means this x minus 1 stuff is going to come out negative, which means that I have to kind of force the stuff inside here to be positive when I get rid of the absolute value symbol. So I'm going to negate everything inside absolute value and rewrite this as y equals negative 2 ln, now parentheses, negative x plus 1. And then I'll have my plus c, which in this case is plus 1. For this problem, I want the particular solution for this differential equation going through the initial condition y of 0 equals negative 1. Let me start with my antiderivative, which is y equals negative 2 cosine of x plus c. Next, I'm going to plug my initial condition in to figure out the c value. So I have a y value here of this negative 1 equals negative 2 cosine of 0 plus c. Cosine of 0 is 1, so this is really just negative 1 equals negative 2 plus c, which means that c must equal 1. And plugging that back in, we have y equals negative 2 cosine of x plus 1 for our final particular solution. For this problem, they're giving us that dy over dx equals cosine of 2x, and they want to know what y is. So they're essentially asking for the general solution to this differential equation. Basically, they just want the antiderivative. Antiderivative here is going to be, let's see, sine of 2x divided by that inner tail of 2. So 1/2 sine of 2x plus c. And looking at our answer choices, that's going to be choice C. For this problem, we're given that f prime of x equals 2 over x, and that f of radical e is 5. We want f of e. So this is essentially a differential equation kind of setup here. At least that's one way you could solve it. At some point, you're going to need to take an antiderivative. But we're essentially starting with the differential equation dy over dx equals 2 over x. So we'll start by taking an antiderivative, which we could say f of x equals 2 ln absolute value of x plus c. And now we're going to plug in what's essentially an initial condition here to figure out this c value. So if I plug in 5 for f of x, that's going to equal 2 times the ln of absolute value of radical e plus c. And since radical e is positive, I don't really need the absolute value there. So let's see here. This is, let's see, we could pop out an exponent of 1/2, because this is the 1/2 power. So this 2 gets canceled out. Then we've just got the ln of e, which is 1. If we subtract that from both sides, we find that c equals 4. And now I have to resolve this absolute value before I plug 4 back in for the c value. So if we have an x value of radical e, that means the stuff inside here, x, is going to come out positive, which means we can just drop the absolute value symbol and replace it with a parentheses, if anything. So we can write this now as f of x equals 2 ln of x plus 4. And now we just have to plug in e, because that's what we ultimately wanted here, f of e. So that's going to be 2 times the ln of e plus 4. So this is just 2 times 1 plus 4, which is 6. So choice D. Another way you could have done this, set it up kind of FTC style. You could have done, let's see, 5 plus the integral from radical e to e of this stuff here, but I think this is a little bit quicker. On this problem, we have a curve with a slope of 2x plus 3 at every point on the curve. So we want the equation for the curve if it has to go through the point 1, 2. One way to do this is to set it up as a differential equation. We can say essentially that dy over dx, the slope of our y function, equals 2x plus 3. And we can think of this point 1, 2 as an initial condition. So let me start by getting my antiderivative, my general differential equation solution. That's going to be y equals, this will be x squared plus 3x plus c. And now let me plug this point in to find my c value. So at the y value 2, we've got 1 squared plus 3 times 1 plus c. So this is all 4 plus c. Subtracting 4, we get c equaling -2. And now plugging that back in, we have y equals x squared plus 3x minus 2, which is going to be answer choice D. For this problem, we want to know which of the following is a solution to the differential equation y double prime minus 4y equals 0. So this is a second order differential equation, which is no longer in the AP curriculum. But you could see it at the college level for a class of differential equations. And yet I maintain there is a way to do this problem even with your high school level calculus knowledge of antiderivatives and whatnot. It's a multiple choice question. So we just need to figure out which of these things, when you prime it twice and subtract 4 times the function, which of those gives you 0. So we're just going to test answer choices until we get something that works. All right. So let's figure out choice A first. Y prime on this one is going to be 2 times e to the 2x. So y double prime then is going to be 4 e to the 2x. And now we're also going to subtract 4 times this function. So this is minus 4 times e to the 2x. And does that come out to 0? Well, yeah, it does. It's the same thing subtracted from itself. So right off the bat, we actually have the right answer here. But just for the sake of argument, let's look at these other ones and see why they are not the right answer. But if you were in a rush and this was the real AP test, you could definitely pick this and move on. But for choice B now, first derivative on that one's going to be just 2e to the x. The second derivative is also going to be 2e to the x. And 4 times this thing, we're going to be subtracting 8e to the x, which does not come out to 0. So that one didn't work. For C, the first derivative was 2 cosine rather of 2x. Second derivative is -4 sine of 2x. If we do 4 times the function, we're subtracting 4 times sine of 2x. And this almost comes out to 0, but not quite. This is actually -8 sine of 2x, so not 0. And then for the last one, first derivative of this function is -2 sine of 2x. Taking another derivative, we have -4 cosine of 2x. And then 4 times this function, we're subtracting 4 times cosine of 2x. This has the same issue we had in part C. These almost cancel, except that this is the wrong sign for canceling, so this does not equal 0 either. So then choice A definitely is the answer.